In this graph, we'll show how the math from section 19b.2 relates to the graphs that we've been drawing. We begin by drawing the demand and supply curves that are derived as the inverses of the demand and supply functions from equation 19.10. Alpha in these equations is set to 1000 and beta is set to 10, and when they're set equal to each other and we solve for the equilibrium price, we get a price of 10. Plugging that back into either function, we get an output quantity of 100. When a per unit tax of T is introduced, equations 19.11 and 19.12 calculate the resulting consumer and producer prices given the tax wedge that has been introduced. When we set T equal to 10 and use equation 19.12, we can determine the producer's price when the per unit tax is 10 will be 6.18, and the new equilibrium quantity will be 61.8. Given the per unit tax T of 10, this implies a consumer price of 16.18, which we could also calculate from equation 19.11. Since the underlying tastes that give rise to the demand function in equation 19.10 are quasi-linear, we can measure consumer surplus on the demand curve. Consumer surplus before the tax was imposed is A plus B plus C, and consumer surplus after the tax is imposed is just the area A. As always, producer surplus can be measured as the area above the supply curve up to the price that producers actually receive. Thus, producer surplus goes from the initial area D plus E plus F to the area F after the tax is imposed. To see how this relates to areas underneath demand and supply functions as opposed to demand and supply curves, we have to invert the picture in panel A. The areas to the left of the curves in panel A then become areas underneath the functions in panel B. The change in consumer surplus from the imposition of the tax, the area B plus C, is then simply the integral of the demand function evaluated from the price of 10 to the price of 16.18, as given in equation 19.13. And the change in producer surplus, area D plus E, is the integral of the supply function evaluated from the price 6.18 to 10, as given in equation 19.14. The change in consumer surplus could also be calculated using the expenditure function that we derive from the underlying tastes. This is done in equation 19.18 and doesn't involve evaluating integrals. The answer we get is the same, but it's useful to see how integrals can be used to evaluate changes in consumer surplus, and how these changes in consumer surplus are areas beneath functions, even though in our pictures of demand and supply curves, they're areas to the left of functions.